so example 3, find the measure of angle A in the triangle shown. And again, I want to find everything. So A, we'll call this B, call this C. And just a thing trigonometry books tend to do when they're naming triangles, they use capital letters to name the vertices, capital A, capital B, capital C. And sides across from those are typically named the same letter, lowercase. So this is lowercase a, lowercase b, lowercase c. Right? If we didn't know some pieces like that, that's typically how they get named. So sometimes they won't even draw the picture in their book, they'll describe a triangle. Find the missing parts in triangle ABC if angle A is 75 degrees, angle C is a right angle, and side A is 44 inches, something like that, right? So they might describe the triangle, you draw the right triangle the way they describe it, and put the missing parts or the known parts opposite those objects. In this case, BC is 11.3, AC is 16.5, so again, if I start taking inventory of what I know, I see a right angle, so it's a right triangle. I know two sides. So I'm going to follow the I know two sides technique. Okay. Very first step is find the third side by the Pythagorean Theorem. So if I'm doing step 1 here, Pythagorean Theorem is hypotenuse squared equals leg squared plus leg squared. So C squared equals 11.3 squared plus 16.5 squared. Grab our calculator, type in 11.3 squared and 16.5 squared to get those numbers. So we get 127.69 plus 272.25. We add those together, so 127.69 plus 272.25. Comes out to 399.94. So C is going to equal the square root of that, which is 19.998. If I'm rounding that to 2 decimal places, this 9, next number is an 8. So I'm going to go until I don't get to a 9. Right there, right? So that 1 becomes a 2, all the 9s become zeros, and the decimal point stays where it was. So C equals 20.00. And if you have to round a 9 up, keep going left until you find a number that's not 9. That goes up 1, all the 9s become zeros. All right, so C is 20.00, and 20.00 is a better answer than 20 because that shows the person who's looking at your work that that's not exactly 20, that's been rounded to 20. All right, so again, gets back to significant ideas, significant digits, things like that. All right, so that's step 1. Step 2, it says pick an acute angle you wish to find. In other words, you get to pick which one you want to find. Now, obviously, the problem says find the measure of angle A, right? So let's say we want to find A. So I'm going to pick an angle I want to find. I don't know what angle A is. In the last problem, we did know an acute angle. We actually knew both of them, so we got to pick one, and everything was set up for us. So here's my acute angle. And then for that acute angle, I want to identify the opposite, the adjacent, hypotenuse. I could have just as easily picked angle B, opposite adjacent hypotenuse. So whichever angle you pick, you got to pick the opposite adjacent hypotenuse for that angle. So I'm picking A. So opposite side, go across the triangle to get opposite. Go from the right angle across the triangle to get the hypotenuse. And then the third side is the adjacent side. Right? Now, it says determine either sine, cosine, or tangent of that angle. Now, let me just give you this little hint on this one. It's not saying to find all 3, it says find 1. Okay, we have 3 numbers in this problem at this point. We have the bottom, 16.5. We have the up and down, which is 11.3. We have the slant, which is 20.00. Which 2 numbers of those 3 are the most accurate numbers? Or exactly what they're supposed to be? And which one is approximately what it's supposed to be? 20. The 20 is approximately, right? So when I'm looking at SOHCAHTOA, and I've got all three of these numbers, whether I do sine equals this over this, or cosine equals this over this, or tangent equals this over this, they're all going to result in the same answer for A. Okay? But there'll be a slight discrepancy based on approximations. So if I have exact values, which are the ones that were given to me, it's best to use the one involving those two numbers. So the exact numbers I know are the opposite and the adjacent, and the opposite and adjacent belong to the tangent. So if I write a trig ratio just for tangent in this particular case, I'm going to get tangent of A equals 11.3 over 16.5. Now the unknown in that picture is the angle measure. All right? So what I'm going to do to find the angle is I'm going to do the inverse tangent of that. So on my calculator, on your calculator, hit the trig button, it says sine, cosine, tangent. You keep arrowing down, you eventually get sine minus 1, cosine minus 1, tan minus 1. I want tan minus 1 of 11.3 divided by 16.5, and then I do it in parentheses. And go ahead and leave it as a fraction. The more accurate you are with your calculator, the more specific you are, the better answer you get. So instead of dividing that, getting some decimal approximation for it, just put that fraction in as it is. Tan minus 1 has that beginning parentheses. You put the quotient in, then put the end parentheses, it equals. And it spits out the angle measure, 34.41 degrees. Oh. 3 and 4 I did together by accident. Now, just to show you real quick, and I wouldn't write this on your paper, just pretend, instead of doing tangent in that step, I did sine. Again, don't write this on your paper, I'm going to erase it as soon as I'm done doing it. But if I did sine of A, sine is defined as opposite over hypotenuse, so it's 11.3 over 20.00. Now it was almost exactly 20, so it's a pretty close approximation, right? So I might get really close to that same answer, but if we try it out, I'm going to get A equals sine minus 1 of 11.3 over 20.00. If I type that in my calculator, inverse sine 11.3 divided by 20.00 equals 34.40. Slight discrepancy, not much, right? But A equals that measure. So it doesn't matter if you do sine or cosine or tangent, A is equal to whatever it equals. So when it says pick one of those, that's what it means, pick one. It doesn't matter which one you pick. But again, I usually go with the one with the measures they started me off with. That's exactly right. Where once I start approximating, I start getting some discrepancy in my answers. So I prefer not to do discrepancies if I can avoid it. Okay, once we finish with that step, the last thing, if they ask me for all this stuff, if I want to know all the missing parts, I just found A is equal to 34.41 degrees. My last step is to find angle B. Well, at this point, this is 90. That's 34.41, so just subtract from 180 again. So angle B plus 90 plus 134.41 is 124.41. And all three angles add up to 180. So if I subtract 124.41, I'm going to get 55.59 degrees. 55 point what? Well, again, if I'm rounding two decimal places, 5.9. And if you'd found the 40 answer instead of the 41 answer, right? Because we used the other thing, right? We had 40. So again, they're pretty much the same. This is the most accurate answers. .40 and .60 are less accurate, but still not wrong. So a couple decimal places. If I'm just doing this math, 180 minus 124.41, it has a 5 nines, 2 decimal places, so that's what I'm looking for.